Right, so you should be continuing on from your notes where you did your adding, subtracting. We're now going to do some distributing and foiling. Within the distributing and foiling, we may have some adding and subtracting. So my first one here is distributing. When you distribute, you want to multiply the first term times the first term. And as before with multiplying, we're multiplying the outsides together first. So the outsides would be 10, and then the insides, 3 times 3 would be square root 9. Then I want to multiply the first and the second. So the outsides multiplied together would be 4, and the insides multiplied together would be 36. Now I actually don't even need to do factor trees here. Hopefully you recognize that the square root of 9 is 3. So this will be 10 times 3. If you have 10 square root of 9, it really means 10 times square root of 9. I know we had already talked about this, but I just want to make sure that's clear, especially when everything comes out of the radical. And then square root of 36 is 6, so this will be 4 times 6. So actually, we're not even combining like radicals here, we're just combining the numbers, because we get 30 and 24, which combines to be 54 for our answer. So some of these might come out to be numbers, some might come out where you're left with some radicals at the end. So let's just do 2 more examples of these, and then we'll jump right into the foiling. So same thing, we'll multiply. This just has inside, so we'll get cube root of 8 minus cube root of 64. Those are actually both perfect cubes also, but if you don't recognize it and you do a factor tree, that's okay. Hopefully you'll realize everything comes out. Cube root of 8 is 2. Cube root of 64 is 4. And you can test those out in your calculator. You have different ways that you can put in cube root. You have the math button. Remember, you also have the option to put in the rational exponent of 1/3. So you can type in 8 to the 1/3, you can type in 64 to the 1/3 and see that those come out to be the whole numbers. And then we'll combine this. 2 minus 4 is -2 for our final answer. I'm going to erase that line because it's not really a division sign, so I don't want you to think that that's part of it. And then my last one, I don't think anything combines, but we might have some simplifying that we'll have to do. 5th root of 16 times 2, 5th root of 2, minus 5. So we'll multiply the 2 is on the outside on its own, and then we'll multiply 16 times 2 is 32. And then here, the 5 is on the outside, so if it helps, you could put a 1 in front of here. 1 times 5 is 5, so this will be 5, 5th root of 16. Now 32 is actually a perfect fifth, but I don't think you'll have these memorized, so if you don't recognize that, you most likely would probably break this down. So I'm going to do that in this example because I think most of you won't recognize that unless you're going with the technique where you're listing out the perfect cubes and fourths and fifths. So I can write them out. I also could write it as 2 to the 5th, but if I circle all 5 of these and they all come out, you don't rewrite the radical. Everything comes out, so it would just be 2 times 2. And then if I break down the 16, I'm not going to get enough 2's to pull anything out. I only get 4 of them, and I need 5. So for that one, I'm just going to bring that down. This is 4 minus 5, 5th root of 16. Oh, sorry about that in the corner. All right, so we have 2 more examples that we want to do here, and these will both be foiling. Whenever you foil, a lot of times you will be doing some sort of combining, especially if you have the same radicals in the foiling situation. I'm actually going to move that down a little so I have enough space to draw my little arcs. So this distributing and foiling are actually a little less work, I think, sometimes than the adding and subtracting ones, because the adding and subtracting, you have to do much more intense simplifying at the beginning. So really we are doing distributing. Foiling is just an acronym to help you with that. I'm going to do 5 times the 3 first and get 15. And then I'll distribute the 5 to the other term. So 5 times 2 is 10. I'll get plus 10 square root 2. And I'll do the same thing along the bottom. Now I'm going to take the negative 2 or negative root 2 and distribute that in. So if I multiply that by the 3, I'll get minus 3 root 2. And then this will be minus 2 square root of 4, because you're doing 2 times 2 on the inside. Now I will be able to combine like terms here. My middle 2 terms a lot of times will be like terms, so I'll combine those. That'll give me 7 square root 2. Also on this last term here, I have a perfect square. So I'm going to be doing minus 2 times 2, which is really 4. And I can do a little bit more combining, because the 15 and the minus 4 should combine together. So we'll get a final answer of 11 plus 7 square root 2. And there are some steps on here that I showed that you might be able to skip, but just be careful you don't skip too much. If you do too much in your head, sometimes that's where you'll start to make mistakes. And then this last one, I'm going to star only because this is going to be a common thing we will do when we get into dividing. I'm going to have square root of 2 plus square root 5, and then square root of 2 minus square root 5. This is actually considered the difference of 2 squares if you were going to do factoring. But we can call it difference of 2 squares when we're multiplying it out also. Because it's difference of 2 squares, the middle 2 terms will cancel. So I'm going to do the multiplying the same way. If you recognize that the terms are going to cancel, you in the future don't have to write them. So square root 2 times square root 2 is square root 4. You could also go right into writing that out as 2. And then square root 2 times minus square root 5 will be minus square root 10. Then I'll go underneath. Square root 5 times square root 2 is positive square root 10. So you'll see that those will cancel. And then square root 5 times negative square root 5 is minus square root of 25. So these middle ones, the minus and the plus, will cancel. And then we get 2 minus 5. So you'll notice they'll cancel, and then you'll also get 2 perfect squares. So your final result is actually also an integer in this case. And that's something that happens frequently when you do this technique as well. All right, so that wraps up the distributing and multiplying video. And now you will have a chance to start working on some practice of the adding, subtracting, distributing, and foiling of the radicals.